Hello, 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 hello.
Hello.
Okay, okay, can hear me, yeah? Yeah. Did you finish the homework, the last week homework?
Yeah.
Yeah, okay. Um, yeah, any specific topic you want to work on today?
Chemistry.
Chemistry. Yeah. Uh, which topic?
Mm,
Which topic are you doing at school now?
mm, acids and bases.
Oh, okay, okay. Acid and bases. Yeah. Maybe we can go through the acid and bases topic. Okay. Yeah, because we start late, so we will finish at 10:50, yeah? Okay. Okay, let's look at the acid and bases. Yeah. Okay. Hold on. Yep. Okay, let's look at the acid and bases topic. Okay. Um, yeah, so I think should be straightforward. Uh, I think we did do this topic before, so I think should be straightforward. Okay, so what is acid? Substance that produce H plus ions. Okay, substance that produce H plus ions. Called protons. Okay, yep. And then bases. Okay, we have two types. Bases that dissolve in water. They are alkali, do not dissolve in water, insoluble bases. Okay, so they produce um, hydroxide ions, and then they are called proton acceptors, accept protons. Okay, indicators, we are very familiar. We have different type of indicator. The main one, litmus, thymoltalin, and metal orange. So we just need to know the color for these three. Okay, neutralization, combine acid and alkali, neutralize to produce water. Okay, so ionic equation, yeah, should be no problem. Okay, yeah. So main point, we cancel the spectator ions. Example, hydrochloric acid and sodium hydroxide. Okay, so we form these ions. Okay, one, two, three, 4, 5, 6. Okay, and then water. So we cancel out the ions that remain the same before and after reaction, like chloride remain the same, sodium remain the same. So we are left with hydrogen ion, hydroxide ion, and water. So this is the actual reaction that happened. Okay. Okay. Strong and weak acid. Okay. We know that acid it gets stronger as the pH decrease. The alkaline it gets stronger as the pH increase. Yep. Okay. Yeah. Universal indicator. So we know color of universal indicator. Okay. So strong acid means it has a higher concentration of H plus ions. Okay. Yep. Okay. So difference between strong acid and weak acid. Okay. They both produce H plus ions. Okay. So they both will produce H plus ion, but strong acid it completely dissociate. Okay. So let's say we put 1 mole of HCl in the water, we will get 1 mole of H plus ions. Okay, fully dissociate. For the weak acid, only a small number dissociate, partial dissociation. Okay, so let's say we put 1 mole of this ethanoic acid. Okay, CH3COOH. Okay, ethanoic acid. So maybe it just gives us 0.01 mole of H plus ions. Okay, so it gives less H plus ion, so it's less acidic. Okay, okay, formation of salt. So we know acid plus alkali can form salts, and then some different compounds we add together, we can also form salts, like it form precipitates. Okay. Yeah. So later we will learn how to um prepare salts. Okay. How to prepare salts. Okay. The step one is to know whether the salt is soluble or not. Okay. So if the salt is soluble or non-soluble, we will choose different method. So the step one is to know whether the salt that we want to prepare is soluble or not. Okay, so yeah, basically we need to memorize this table. Okay, which salts are soluble, which ones are partially soluble, which ones are insoluble. Okay, so partially soluble is easy, calcium hydroxide. Soluble or nitrate, anything is ending with nitrate is soluble. Okay, anything ending with nitrate is soluble. Okay, uh or sodium, potassium, ammonium, anything starting with sodium, starting with potassium, starting with ammonium, they are all soluble. So it can be any anion. Okay, as long as we start with sodium, potassium, ammonium, they will be soluble. Most of the chloride, okay, most of the chloride, like sodium chloride, okay, or copper chloride, okay, most chloride are soluble except lead and silver, okay, uh, lead and silver. These two are insoluble. Exceptions. Okay, most of the sulfates, they are soluble. Sodium sulfate, okay. Copper sulfate, they are soluble. Exception, okay. Lead, okay. Sulfate, okay. Calcium sulfate, and barium sulfate. Exceptions. Okay. Lead nitrate, okay, is soluble. Lead nitrate. All other lead salts, okay. Everything else insoluble. Okay. So yeah, lead anything, okay, is insoluble except for lead nitrate. Okay. Okay, sodium, potassium, ammonium, carbonates. Okay, only these three: sodium, potassium, ammonium. Sodium, potassium, ammonium. Okay, carbonate are soluble. All other carbonates. Okay, copper carbonate. Okay, yeah, zinc carbonate. Okay, so they are all insoluble. Okay, sodium and potassium hydroxide. Okay, yeah, sodium and potassium hydroxide. All other hydroxide will be insoluble. Yeah, like copper hydroxide. Okay, and so on. Yeah, iron hydroxide. Okay, so they will be insoluble. Okay, so just need to memorize this table. Okay, next. Yeah. three categories, okay, of oxide. Okay, acidic oxide will be non-metal plus oxygen. Okay, will be acidic oxide. Okay, they can neutralize alkali to form salt. Okay, example CO2, SO2, dissolve with water to form acid. Okay, basic oxide, they are metallic oxide. Metal plus oxygen turns to uh, basic oxide. Okay? Yep. They can neutralize acid because they are basic. Example, calcium oxide, copper oxide. Okay, they dissolve in water to form alkaline hydroxide. Okay, others are insoluble in water. Okay, okay. Some metallic oxide, they are amphoteric. Okay, so amphoteric means they can react with both acid and bases, form salt and water. Example, zinc oxide, aluminum oxide. Okay, yeah. Methods for preparing soluble salts. Okay, so first, step one, we need to make a salt. Okay, step two, we want to find out whether it's soluble or insoluble. Okay, so if it is soluble, we have different methods. Insoluble, we have different methods. Okay, yeah. So okay, so normally we use acid. We use acid. Okay, if we want to prepare like anything chloride, we will use hydrochloric acid. Anything nitrate, okay, let's say copper nitrate, we will use nitric acid. Okay, anything sulfate, we will use um sulfuric acid. Okay, so and then there are different methods to do this. Okay, so either we can add acid to metal, add acid to base, add acid to carbonate, or we can do it by titration. Okay, yep. So the positive ion in the salt comes from the metal. Okay, let's say we want to make uh let's say we want to make zinc chloride. Yeah. Okay. Let's check. Yes. Let's say we want to make zinc chloride. It is soluble. Okay, so we can put zinc metal. Okay, the acid will be hydrochloric acid. Zinc metal. Okay. Uh, zinc oxide, zinc carbonate, or um soluble base by titration. Okay, alkali soluble base by titration. So this one, we need to use the alkali, which we can have zinc hydroxide. Okay, but zinc hydroxide is insoluble in water. So which means this one we can use A, B, C only. D we cannot use. Okay, only when we have it is soluble, then we can use the titration. So not all of the methods are suitable. Okay. Yes. Example. Okay, let's say we want to prepare zinc sulfate. Okay, so zinc sulfate, the zinc coming from the metal, the sulfate coming from the acid, so we get the zinc sulfate. Okay, yep. Solid metal disappears, bubbles are seen. Okay, so this is the observation. So the zinc will dissolve and then the bubbles are coming from the hydrogen gas. Okay, yeah. So okay, so here the key point is we will find that preparation of salts. One very important points. Okay, important point. We want a pure product. Okay, we want a pure product. Okay, so this zinc sulfate, we want a pure product, not mixed with other things. So what do we do? Okay, what do we do? Normally, we will put, let's say we put sulfuric acid in excess. Okay, and then zinc metal is limiting reagent. Okay, so if we put like this, is wrong. Okay, why? Because the zinc metal limiting it fully reacted, but the sulfuric acid is still present. Okay, because it's in excess. So now we have in our product, we will have sulfuric acid and the salts mixed together. Okay, reactant and product mixed together, we cannot separate. Okay, so we cannot separate, so we cannot get a pure product. So this is not the correct way to do it. Okay, excuse me. This is not the correct way to do it. So for this kind of reaction, it's always the metal will be excess. Okay, because it is solid. Okay, so the acid normally it will be limiting reagent. Okay, because it's dissolved in water. Okay, yeah, aqueous. So we always put the solid in excess, then the acid will be fully reacted. Okay, the acid is fully reacted. The excess solid, there will be some remain, but no problem because this one we can filter to remove. Okay, we can filter to remove the solid so we can get a pure product. Okay, yep. So not only we need to choose the correct reagent to mix together, we also need to think which one we need to put in excess, which one is limiting reagent, so that we can get a pure product. Yeah, so this is a key point for preparation of salts. Not only we want to get a product, we want to design the experiment such that we can get a pure product. We can separate the unreacted reactant. Okay. Yep. Acid and base. Okay. Acid and base. Yeah. So okay. Insoluble bases. So we can have example magnesium hydroxide insoluble. Okay. This one is soluble. Okay. So this is a solid. So again, we will put this in excess. Okay, this one is limiting. Okay, so this one will be fully reacted. Okay, this one will be remain some. Okay, but this one is no problem. We can filter it to remove the solid so we can get a pure product. Okay. Yep. So in this case, no gas will be produced, no bubbles, but we can see the solid dissolve. Okay. Yep. Another example, acid can react with bases to form salt and water. In the case of ammonia, ammonium salt is the only product. Okay. So let's say, yeah. So usually acid plus base will give us salt and water, no gas produced. Okay, acid. Let's say we have HCl and then we have ammonia. Okay, so now this hydrogen and ammonia, okay, they will combine together to form ammonium. Okay, so in the end, we have ammonium chloride as the final product. Okay, so this is for ammonia. Okay, acid plus carbonate. Okay, yep. So we know carbonate is mostly insoluble. Okay, okay, acid soluble. Okay, so again, this one we will put in excess. This one will put in limiting. Okay, so this will be fully reacted. Okay, so this one we will remain some. Okay, but no problem. We can filter to remove this copper carbonate. Then we can get a pure product. Yeah. And then carbon dioxide will leave as a gas, and then water, we can also separate it. Okay. So observation, solid carbonate will disappear. Bubbles, we can see the bubbles of carbon dioxide. Okay. So finally, acid and alkali. Okay. So this one, it will be titration. Titration. Okay. So the alkali, this is soluble. This is soluble. Okay. Yeah. So if both soluble, we cannot, in the end, we cannot filter to remove the excess reactant. Okay. If we put one of them to um, excess, in the end, we cannot filter it because they are soluble in water. So for this situation, if we have soluble, we must do titration. Okay. Why we must do titration? Because it will give us exactly same amounts. Yeah. Okay. So if we can get exactly same amount, no excess, then we can get a pure product. Yeah. We don't want extra sodium hydroxide or extra acid with our product. We cannot separate it. Okay. So it must be exactly the same amount. So we must do titration. Because titration can give us exactly the same amount, because when it reach the same amount, there will be color change of the indicator. Okay. Yep. So method one, okay, for the method one, for the soluble salts. Okay. So method one is when we have solid reactant. Okay, solid reactant like solid metal, metal oxide, metal hydroxide. Okay, yeah. So normally we put in excess. Okay, we put in excess, no problem, because the excess solid can be removed by filtration. Okay, yep. And that is another key point. Uh, for copper metal cannot be used, but other like zinc, iron, okay, other metals it can be used for metal, but copper cannot because it's lower than hydrogen in the reactivity series. This one we will learn later. Okay, copper 2 oxide, copper hydroxide or copper carbonate can be used. Okay, so let's say we use copper oxide, sulfuric acid, we will get the copper sulfate salt, okay, and then the copper oxide we can filter. Okay, so step one, add solid copper oxide. Okay, stir, continue adding the solid until it no longer dissolve. It means that all acid has reacted, solid is in excess. Filter to collect the excess solid unreacted one. Okay, and then we can crystallize the product, make pure crystals by crystallization and then washing and drying. Okay, okay, the method two, okay, if we do titration. Okay, so when we do titration, when both of them are soluble. Okay, so when both of them are soluble, we cannot put in excess, must be exactly the same amount. Okay, so this one we will do titration. Okay, yep. So we want neither in excess, both of them equal amount. Okay. So let's say we put the sodium hydroxide, sodium hydroxide at here. Okay. Okay. So this one, sodium hydroxide, and then acid. Okay. So we will drop the acid until color change of the indicator. Okay. So when indicator color change, so means we have exactly the same amount of the hydrochloric acid and sodium hydroxide. Okay. When they are exactly the same amount, then we can get a pure product. Okay. Yep. Example, sodium sulfate. If we want to produce sodium sulfate, the sodium hydroxide, it is soluble. The sulfuric acid, they are also soluble. So if both of them soluble, we must use titration. Okay. Yep. So first, we put the pipette, the sodium hydroxide in the conical flask. Okay. And then add 2 or 3 drops of the indicator. Okay. Sodium hydroxide with the indicator. And then we have the burette. Okay. With the sulfuric acid. Okay. And then add the sulfuric acid to the conical flask, swirling it as we go. Continue until the end point. Until the end point is when color change happens. Okay, so we get approximate volume of the sulfuric acid. Let's say we start with 25 cm cube of the sodium hydroxide. Now the sulfuric acid is maybe we need 20 cm cube. Okay, example, because they have different concentration, even if they have the same mole, even if the mole is the same, because the concentration is different, the volume will be different. Okay, let's say this 25, this is 20. Okay, so now let's say we know the approximately value is 20 cm cube. Now we will repeat accurate titration. Okay, when the endpoint is close, let's say we reach 19.5, we will slow down, add drop by drop. Okay, until the indicator change. And then we will repeat 2 or 3 times until we get the difference is between 0.1. Yeah, so let's say we get 19.8, 19.9, then okay, it's done. Okay, and then we will, because our objective is to form these salts, right? Sodium sulfate, we want a pure product. Okay, even if we have the indicator, it's still not a pure product. So now we already find out the accurate answer is, let's say 19.8, 19.9. We take average 19.85. Okay, so now we will repeat without indicator with the same volume of acid and alkali. So 25 cm cube of the alkali, 19.85 cm cube of the acid. Okay, and then yeah. So these are the steps to get a pure product. Okay. So we can so in the end we have the sodium sulfate in water as a solution. So and then we will crystallize, okay, to collect the sodium sulfate crystals. Okay. Yep. Okay. Reaction of bases. Okay, so this is another example. Um Bases neutralize acid. Okay, insoluble base, alkali react when heated with ammonium salts. Okay, so this is another more unusual reaction. Okay, so this is base. Okay, this ammonium salt is actually acid. Yeah, it's actually acid. Why? Because this ammonium, it can uh, break down to form ammonia and the H plus. Yeah. So the H plus, okay, this H plus will react with OH to form water, and then the ammonia, okay, will become the ammonia product, and then the calcium and chloride will react together to form the salt. This is another reaction. Okay, just now we already go through all the steps for soluble salts. Okay, we already go through the step for soluble salts. What if we want to prepare insoluble salts? If we want to prepare the insoluble salt, we have a different method. Okay, we have a different method, meaning our product is insoluble. Okay, insoluble. Okay, same idea. We want a pure product. Okay, so if we want a pure product, means we want to filter to collect our product. If we want to filter to collect our product, which means this one must be soluble. All of this must be soluble. Okay, so that we can filter to collect the product. Okay, yep. So which means for in order to prepare the insoluble salt, we must choose the reactants. They must be soluble. Okay, so that's the main point to prepare the insoluble salt. Okay, yeah. So insoluble salt are prepared by precipitation. Okay, mixing two aqueous solutions. Okay, insoluble solid forms a precipitate which can be separated and purified. Okay, so lead sulfate can be made by this method. Okay, yep. So okay, lead nitrate. Okay, okay. So let's say we want to produce the lead sulfate, which is insoluble. Okay, so lead and sulfate. Okay, so this part we must get from the soluble source, which is sodium sulfate, soluble. Okay, the lead we also need to get from a soluble source. For example, lead nitrate. Okay, so both of the reactants must be soluble. Okay, yep. So that's the idea. So in the end, okay, so these are our steps here. Okay, hold on. Okay, the steps. Okay, so so let's say we have lead nitrate. Okay, okay, sodium sulfate. Okay, so we mix together, we'll form the white precipitate of the lead sulfate. Okay, white precipitate of the lead sulfate. Two aqueous solution of soluble substances are mixed in a beaker. So we start with soluble and then soluble. Mixed together, we get the white precipitate, the product. So now we will filter to get the precipitate. Okay, so we collect the lead sulfate at the filter paper. So the filtrate is just the reactants. Okay, so the reactants that remain. Okay, and then okay, the filtered precipitate is rinsed with distilled water. So now we add more water to wash the product. Okay, and then in the end, the insoluble salt we put in the evaporating dish. Okay, or crucible and dry in an oven. Okay, so this is how we collect the product for the insoluble salts. Okay, yep. So we can also work out the ionic equation. So we cancel the nitric ions that have no change before and after, and the sodium ions that have no change. So we end up with this ionic equation. Okay. Yep. The other point we need to pay attention is testing for different salts. Okay, it's also under this topic. Okay, so let's say we are given like um a colorless crystals. Okay, so we are given some colorless crystals. We want to find out what ion. Okay, what positive ion and what negative ion in this sample. So we need to do a test. Okay, so we have tests for anions. Okay, so these are the anions that we need to know how to test for IGCSE in. Okay, chloride, bromide, iodide, carbonate, sulfate, nitrate. Okay, so chloride, bromide, iodide is the same test. Dilute nitric acid and then followed by aqueous silver nitrate. Okay, so we will get chloride, we will get white precipitate, bromide, we will get cream precipitate, and then iodide, we will get yellow precipitate. So if we get this observation, then we will know whether it's chloride, bromide, or iodide. Okay, if we want to test for the carbonate ion, we will add the dilute acid. It will produce the bubbles. Okay, gas given off will turn lime water milky. It will turn lime water milky, means it is carbonate. Okay. Okay, next one. If we want to test for the sulfate, add dilute nitric acid and barium nitrate, it will form white precipitate. So that is test for sulfate. If we want to test for nitrate, we'll put sodium hydroxide and then aluminum, warm gently, and then it turns damp red litmus paper um, to blue. Okay, like this, from red to blue. Okay, yeah. So this information, it will be given in the exam. Okay, so it's given in the exam, so we don't need to worry about that. So we just need to know how to use it, the information. Okay, so another one, water of crystallization. Okay, so some of the salts, like let's say copper sulfate and cobalt chloride, they not just a pure salts, they also contain water as part of the crystalline structure. So we can see this example here. Okay, so this one is the copper. Okay, this is the sulfate, and then they are associated with the water molecules like this. Yeah, associated with the water molecules. So this is called water of crystallization. Okay, so this can be useful because the copper and cobalt, we can use it as a detection for water. Okay, so when we remove the water, it's called anhydrous. Okay, they have different color. Hydrated copper sulfate is blue color. Okay, anhydrous is white. Okay, like this. Okay, cobalt. Okay, um, okay, cobalt hydrated is pink, like this. Anhydrous is blue, like this. Okay. Okay, next. Okay, for each of the soluble salt, name two substances that can be used to prepare the salts. Okay. Yeah. So step one, we need to identify whether it is soluble or not soluble. Okay. Step one. Okay. So zinc nitrate, we know all nitrate are soluble, all potassium soluble. So they are both soluble and soluble. Okay. So the zinc, okay, we can use the example zinc hydroxide, zinc carbonate, zinc oxide, metallic zinc, and then nitric acid. Okay. Example, let's say we use zinc oxide plus nitric acid. So it will give us zinc, nitrate, okay, and water. Okay. Yep. So another key point is this is solid. Okay. This one must put in excess. Okay. This one must put in excess because uh, later on we can filter to remove the insoluble reactant to collect the pure product. Okay. Yep. Potassium chloride. Okay. So potassium chloride, because potassium is always soluble. Okay. Potassium is always soluble. So let's say we use potassium hydroxide soluble. Okay. Chloride, we use hydrochloric acid. So they are both soluble. When both soluble means we cannot have excess, means we must use titration. Okay. So for this situation. Okay. Yep. Okay. Write word equation between dilute hydrochloric acid and zinc. Okay. Okay. Hydrochloric acid plus zinc will form zinc chloride and hydrogen. Okay. So we want zinc plus hydrochloric acid, magnesium carbonate plus hydrochloric acid, and calcium chloride plus hydrochloric acid. Okay. Yeah. Okay, so maybe this question you can practice and then you can tell me what are the products. Okay. So let's say we add zinc and hydrochloric acid. What are the products? Okay. You can tell me what are the products. Zinc plus hydrochloric acid. What will be the products? Okay, you can try and let me know for this one. Okay, zinc plus hydrochloric acid. Okay, what do you think? Zinc plus hydrochloric acid. What is the product?
Zinc chloride.
Yes. Zinc chloride. And then the other one?
Hydrogen.
Yes, hydrogen gas. Okay. Second one, magnesium carbonate plus hydrochloric acid. There are three products. Okay, so try to give me the products. Okay. Okay, try to give me the products. Magnesium carbonate is MgCO3. Okay, carbonate plus hydrochloric acid. Okay, so what are the three products?
Magnesium chloride.
Mm-hmm.
Hydrogen and CO2.
Close. Okay, it
Water.
is, yes, CO2 and water. Okay. Yeah. So we can take a look. Magnesium carbonate plus hydrochloric acid. Okay. So first we need to balance. Yeah. Okay. Because Mg is 2 plus, so chloride is -1, so will be MgCl2. Okay, and then 2 hydrogen combined with 1 oxygen to form the H2O, and then in the end we are left with the CO2. Okay, okay, next one, calcium oxide plus HCl. Okay, calcium oxide plus HCl. Calcium oxide. Okay, so we should form 2 products. Okay, try to work out the 2 products.
Calcium chloride in water.
Yes, correct. Okay, the other one is we need to write balance equation. Okay, balance equation between these three. Okay, magnesium, copper carbonate, and potassium hydroxide. Okay, added with sulfuric acid. Okay, okay, added with the sulfuric acid. Okay. Okay. So this one, we need to balance the equation as well. Okay. Yep. Okay. So for this one, I need you to, tell me, okay, what are the products and also how many moles? Okay. The products and also how many moles? Okay. So the first one, magnesium plus, magnesium plus sulfuric acid. Okay. What are the products and how many moles? Okay. Okay, so magnesium plus sulfuric acid. What are the products? Okay, try out and let me know. Okay, for question one, what are the products? Okay, try to get the products and also how many moles. Okay,
Magnesium sulfate.
yep. Okay, so we'll get magnesium sulfate and the other product.
H2.
Yes. Okay. Hydrogen gas. H2. Okay. So now we need to find out how many moles of the each one. Okay. How many moles? Okay. So the magnesium, we will put how many moles?
1.
Yes. Sulfuric acid, Okay, magnesium sulfate.
1,
Okay, and hydrogen gas.
1.
Yes, excellent. Okay, let's try question 2. Copper carbonate plus sulfuric acid. Okay, so what kind of product we will get? Okay, what kind of products we will get?
Can I go to toilet?
Yes, yeah, I will go too. Okay, see you soon. Okay, okay, I'm back. Okay, hello, hello. Are you back? Hello, hello. Are you back? Hello, hello. Hello, hello.
Yeah.
Okay, okay. You are back, yeah? Okay, that's good. Um, yeah. Let's continue the question 2. Okay, so now it's around 9:45, so we have about 1 hour to go. We have about 1 hour to go. Okay, copper carbonate plus sulfuric acid. Okay, so try to work out the products, and then so we expect 3 products. Okay, try to work out the products and the number of moles. Okay, what products we expect to have?
Copper sulfate,
Okay,
carbon dioxide, and water.
yes. Okay. Okay, so how many moles of copper carbonate we will add? How many moles?
1,
Okay. The sulfuric acid?
1,
Mm-hmm. Okay, so we will end up with copper sulfate. How many mole?
all of them 1,
Yes. 1 mole copper sulfate, 1 mole carbon dioxide, and 1 mole of water. Okay. Yeah. Let's try the next one. Potassium hydroxide plus sulfuric acid. Okay, what will be the products and how many moles?
K2SO4,
Okay, excellent.
NH2O,
Yes. Okay, how many moles for the KOH, potassium hydroxide?
2,
2. Yes. Okay, 2 and sulfuric acid?
1,
Yes. Okay, potassium sulfate,
1,
okay, and water?
2.
Yes. Okay, excellent. Okay, that's good. That's good. Yeah. So the answers here. Okay. Yep. Yeah. So this is the exam style questions. Okay. So we can go through together. Okay. Okay. Let's take a look together the questions. Okay. There are two general methods. Okay. Two general methods for the preparation of soluble salts. Okay. So if we want to prepare soluble salt, we have method 1 and method 2. Okay. So the first one is adding excess of the insoluble base or insoluble carbonate or metal to a dilute acid. Okay. So example, a yeah, zinc oxide, zinc carbonate, or zinc metal to the dilute acid. Example. Okay. The second method is titration using acid and alkali. Okay, or a soluble carbonate. Okay. For each of the following salt preparation. Okay. So actually we have two questions here. Okay. We need to prepare two salts. Okay. So for each one, we need to answer this. Okay? I. Okay? And I. Okay? And then for B also, we need to answer and I. Okay? Yep. So, okay, maybe easier if I bring this table here. Yes. Okay, this one a little bit messy. Okay, hold on. Hold on. Excuse me. Okay, so this is the worksheet we will practice on later. Okay, let me just open. Okay. And then, okay. Okay. Let me just copy this. Okay. So it's good to know solubility rules. Okay. So the rules of solubility. Okay. Okay. This one, it may be useful. Okay. Put it here. Okay. Yep. Solubility rules. Okay. Yep. So for first question, okay. So for first one, we want to produce cobalt chloride. And then we starting with cobalt carbonate. Okay. So which means it's like this. Okay. Like this. And then, okay. 3 products. Okay. So, now, okay. I think maybe we don't need this one for now. Okay. Okay, so we are preparing cobalt chloride. Okay, cobalt chloride. So this is what we want to prepare. We starting with cobalt carbonate. Cobalt carbonate. Okay. So cobalt carbonate is insoluble, is solid. Okay. How about cobalt chloride? Okay. Cobalt chloride. So the chloride, it will be soluble except lead and silver, but we have cobalt chloride. Okay, cobalt chloride, it is soluble. Okay, so cobalt chloride, it is soluble. So we are preparing a soluble salt. Okay, so now, um, first we need to work out which acid, okay, which acid we should use. Okay, you can try to answer which acid we should use to produce cobalt chloride. Okay, try to work out which acid we should use to produce the cobalt chloride.
hydrochloride.
Yes, HCl. Yes, we will put the HCl. Okay. So we should choose method 1 or method 2 for this cobalt chloride to produce the cobalt chloride. Is it method 1 or method 2? Method 1, adding excess insoluble base to acid, or we use titration. So for this one, it should be method 1 or method 2. Choose method 1 or method 2. What do you think? Okay, to prepare this cobalt chloride, we should use method 1 or method 2. Okay, if you're not sure, you can make a guess, then we can discuss. Okay. Okay, what do you think? To prepare this cobalt chloride, we should use method 1 or method 2.
Method 2.
No. It should be method 1. Can you see? This one, carbonate is here. This one is cobalt carbonate. Okay, so it should be method 1. Okay, method 1 is when we have insoluble plus soluble. Okay, so method 2 is when we have soluble plus soluble. Soluble plus soluble. Okay, so actually titration is harder to do. It takes a long time to do the titration, and then you need to repeat. Okay, so actually titration is harder. Okay, so if we can avoid it, we will avoid it. Okay, only when we have soluble plus soluble, we we must have exact same amount. Okay, we must have exact same amount. We will use the titration. Okay, so for this one, when we have insoluble plus soluble, okay, and then the product is soluble. Okay, the product is soluble, so this one, it will be limited, this one will be excess. Okay, the insoluble excess is no problem because we can filter to remove it. Okay, no problem. But this one, the acid, we cannot access because if we access, later we cannot separate from our product. Okay, so that's the problem. Okay, so for this situation, because we have insoluble plus soluble, So in this situation, we will use the method 1. Okay, so it's easier. After we finish, we just filter to remove the copper cobalt carbonate. Okay, yeah. So we already finished. I name any additional reagent which is required. Okay, what else we need? Okay, they already told us we need to put cobalt carbonate. So what else we need to put? Just now you already told me hydrochloric acid. Okay, so we need to add hydrochloric acid. Okay, now finally we want to work out the equation. Okay, we want to work out the equation. So okay, so we are starting with cobalt carbonate, adding with the hydrogen chloride, hydrochloric acid. So our product is cobalt chloride. And what are the other two products? What are the other two products? Okay. What are the other two products? Okay. Um, Cobalt carbonate plus hydrochloric acid. We get the cobalt chloride salts. What are the other two products?
Water and CO2.
Yes. Okay. Carbon dioxide and water. Okay. Now, how many moles? Okay. Cobalt carbonate, how many moles? Cobalt carbonate, how many moles? Okay. The reactant cobalt carbonate, how many moles? Okay. Try to balance the equation and let me know. Cobalt carbonate, how many moles? Okay, what do you think? Cobalt carbonate, how many moles? This reactant here. Okay, try to balance the equation and then give me the answer. Okay, can get the answer for balancing this equation. Hello, hello. Can get the answer? Hello, hello. Yep. Okay. Give me the answer when you are ready. Okay.
Carbonate.
Okay. Cobalt carbonate, how many moles?
Um, 1.
Yes. Hydrochloric acid.
1.
Okay. Hydrochloric
Oh,
acid.
2.
Yes, 2. Okay. Cobalt chloride.
Uh, 2.
Cobalt
No,
chloride should
1.
be,
My bad.
yes, 1. Yes. COCl2. Okay. Should be 1. Carbon dioxide.
1.
Okay. And water.
1.
Yes. Okay. Excellent. Okay. We can check the answers. Okay. Yep. Just now what we work out. Okay. So we will choose the method 1 because this is insoluble plus soluble. We will use the method 1. Okay. So additional reagent, we need to add the hydrochloric acid in order to get the chloride. Okay. Balance equation. Yeah, just now. Cobalt carbonate plus 2 hydrochloric acid form cobalt chloride salt plus carbon dioxide and water. Okay, now we will look at question 2. Question B. Okay. Okay, question B. Yes. Okay, okay. Question B. So again, we have reactants. Okay, okay, reactant and products. Okay, okay, reactants and the product. Okay, so we want to form potassium nitrate. We want to form potassium nitrate, which is KNO3. Okay, because the charge is +1 for potassium, -1 for nitrate, just KNO3 from potassium hydroxide. Okay, potassium hydroxide. Okay, now, first, let me know what acid we need to use. What acid we need to use. Okay, try to figure out what acid we need to use to get this product. Okay, which acid we should use to get this product, potassium nitrate. So the potassium, we already can get it from the potassium hydroxide. So we need the acid that will give us this nitrate. Okay, which acid can give us the nitrate ion?
Hydronitrate.
Yep, nitric acid, hydrogen nitrate. Okay, yeah, okay. So we need the nitric acid. Okay, and then potassium hydroxide, we know anything potassium is soluble. Okay, anything potassium is soluble. So this is aqueous, soluble. Okay, nitric acid. Okay, so nitric acid is always soluble. Okay, soluble. Okay, so now we need to answer the question one. Question I, we choose method one or method two. What do you think?
Water.
Okay, we should choose the method one or method two for this reaction to produce the potassium nitrate salt. So it should be method one or method two. So method one, we will take the excess insoluble base, insoluble carbonate or metal mixed with dilute acid. Method two, we will do titration of acid and alkali. Okay, so for this reaction here, potassium hydroxide plus nitric acid, is it method one or method two? Which one is suitable? Okay, you can try to think
Two.
about correct. Excellent. Okay, we will use method two. Okay, why? Because both of them are soluble. KOH soluble, nitric acid soluble. So if we put one of them excess, later we cannot separate it. Later when we don't want it, we cannot separate it. So we must have exact same amount. So how we can get exact same amount is by titration. Okay? Yeah. So part two, I name any additional reagent. So just now we already mentioned the additional reagent is the nitric acid. Okay, write the equation. Okay. So now, okay, try to work out the equation and balance the equation. Okay. So first tell me what is the second product. So we know one of the product is the potassium nitrate. What is the other product? Okay, what is the other product here?
Water.
Yes. Okay, water. Okay, now try to balance the equation. Okay, and let me know how many moles of the uh, potassium hydroxide. Okay, so how many moles of each? Okay, try to balance the equation. Okay, try to balance the equation.
One. No, two.
Yes. Actually it's one. Actually it's one. Because one potassium, one nitrate. Yeah, because potassium is 1 plus, nitrate is negative 1. So we only need one each. Okay, potassium, one nitrate. So potassium hydroxide is 1. How about nitric acid? So how many moles of nitric acid?
Also one. Everything one.
Yes. Yes, correct. Everything is 1. Okay, so it's balanced. Okay, let's look at the answer. Okay. Yeah, so we'll choose the method 2, the titration. Okay, because we want exact amount. And then the additional reagent, we will put the nitric acid, which will give us the nitrate ion. And then balancing the equation, everything is 1 mole. Okay, excellent. Okay, let's look at question 2. Okay, give full experimental details how you would make pure dry crystals of magnesium sulfate starting with magnesium carbonate. You should include equation in your answer. Okay. Okay, so first, our objective is to make magnesium sulfate. Okay. First, okay. Uh, so our objective is to produce the magnesium sulfate. Okay. So this is our objective. Produce magnesium sulfate. Okay, so first tell me, magnesium sulfate, is it soluble or insoluble? Soluble or insoluble?
Insoluble.
Okay, so you see, insoluble sulfate only got three. Insoluble sulfate only lead, calcium, and barium. Means other will be soluble. Yeah, any other will be soluble. The only insoluble one with lead, calcium, and barium sulfate. So means magnesium sulfate will be soluble. Okay, magnesium sulfate is soluble. Okay, and then another question is we will use method 1, okay, or method 2. Okay, so method 1 is insoluble, okay, um, metal, okay, or base or carbonate, okay, carbonate plus acid, okay. The other method 2 is titration, okay. So we are starting with magnesium carbonate, okay. So our situation is like this, okay. A okay. So we have two reactants on. Okay, we have two reactants and then three products. Okay, three okay, three products. like this. Okay. So just now we already mentioned we want to produce the magnesium sulfate, which is soluble, aqueous. Okay. And then we are starting with magnesium carbonate. Okay, magnesium carbonate. Okay, let's check. Magnesium carbonate is soluble or insoluble? What do you think? Magnesium carbonate is soluble or insoluble? Okay, magnesium carbonate is soluble or insoluble? Okay, what do you think? Magnesium carbonate soluble or insoluble?
Insoluble.
Correct. Excellent. Okay, so we know sodium, potassium, ammonium, uh, only these three carbonates, they are soluble. All other carbonate will be insoluble. So this will include magnesium carbonate. Okay, so this one is insoluble. Okay, so second question. Now we want to make magnesium sulfate. So means which acid? Okay, which acid we want to use at here? Which acid? Okay, which acid we want to use to get the target product of magnesium sulfate. Okay, so this is what we want. We want magnesium sulfate. We already have the magnesium is coming from the carbonate. Okay, so which means we need sulfate. Which acid we can use that will give us the sulfate? Okay, which acid we can use to give us the sulfate?
Hydrogen.
This one, right? H2SO4. Yeah, okay. So we will use sulfuric acid to give us the sulfate. Okay. Okay. Now our question is we should use method 1 or method 2. Is it we take the insoluble carbonate plus acid or we use the titration? Okay. Is it method 1 or method 2? Okay. So method 2 is titration. And then method 1 is to take the insoluble um, metal or metal oxide or metal hydroxide, okay, or metal carbonate, okay, to add with the acid. Okay, so we can see straight away it must be method 1. It must be method 1 because we have the magnesium carbonate which is insoluble, okay, added with the acid, okay, it will be method 1. Okay, and then the magnesium carbonate will be in excess. Okay, not method 2, we are not doing titration because titration is soluble plus soluble, like KOH plus hydrochloric acid, both soluble, we will use titration. Okay? Yeah. So will be method 1. Okay, now what are the other products? Okay? What are the other 2 products? Okay? Yeah. Try to think of the other 2 products and try to balance the equation. Okay? And then let me know your answer. Okay, what are the other 2 products? Okay, so we have magnesium carbonate plus sulfuric acid produce magnesium sulfate. How about the other 2 products?
One.
Okay, 1 magnesium carbonate, correct? Sulfuric acid?
One.
Yes. Okay, magnesium sulfate.
One.
Okay, what are the other 2 products and how many moles?
H2O and CO2.
Yes. Okay, so how many moles of the water and how many moles of the carbon dioxide?
One. One.
Yes, yes, correct. Excellent. Okay, yeah, let's look at the answer. Okay, so basically, these are all the information that we need. Okay, yep. Okay, look at the answer. Okay, and okay, so first, okay, we need to give the exact step. Put dilute sulfuric acid into a beaker. Okay. Okay. And then we add the magnesium carbonate. Okay. Magnesium carbonate, stir or warm. Okay. We keep adding magnesium carbonate until it start to be undissolved. Okay. Or no more bubbles of gas are involved. So means it's already in excess. The reaction completed. And then this is a key step. We filter off excess magnesium carbonate. Okay, so we remove the reactants that are excess, and then yeah. So just now our equation here. Okay, remove the excess magnesium carbonate, and then now we have our pure product. Okay, of magnesium sulfate because carbon dioxide will be removed as a gas and then the water can also be removed. Okay, so what are the next steps? Heat the filtrate until crystals form on a glass rod, place in the solution and withdraw. Okay, until we get a saturated solution, and then we leave the saturated solution to cool down, then we will form the crystals. Okay, and then we will collect the crystals by filtration, and then we dry the crystals in an oven or warm windowsill. Okay, so that's the idea. Okay, so now it's 10:30. We will continue a bit more. Okay, because we started late. Okay, now student titrated hydrochloric acid with aqueous ammonia using the apparatus below. Okay, no problem. Okay, let me copy the question. Okay. Okay. Uh, okay. The questions. Yeah. Okay. Question A. Name apparatus A and apparatus B. Okay. Straightforward, right? Okay. Name apparatus A and apparatus B. Okay. You can try, straightforward. What is A? What is B? Okay. Can remember? What is apparatus A? What is apparatus B? Okay. Can get the answer? Name apparatus A and apparatus B. Okay, what is this apparatus A here and what is this apparatus B?
Burette.
Yes. Okay. A is burette. Okay, how about B?
Conical flask.
Yes. Conical flask. Okay, B. Titration is carried out in order to measure the exact volume of hydrochloric acid that is required to neutralize the ammonia. Okay, so ammonia is alkaline. Okay, the hydrochloric acid is acidic. Okay, so we will add the hydrochloric acid to the ammonia until it's fully neutralized. Okay, okay, so means will be exact same amount. Okay, so there will be exact same amount of the acid and alkali. Okay, okay, now B1, question B1. Name the type of substance that should be added to the ammonia before the acid is added. Okay. Okay. Before we start the titration, we need to add something here. Okay. What is it we need to add? Okay. Try to think about that. Okay. What we need to add.
Mm,
Okay. Every time we do titration, what we need to add?
carbonate.
Mm, we need to add indicator. We need to add a indicator, right? Because we want to know when it's fully neutralized, when they have exact same amount. When fully neutralized, there will be a color change of the indicator. Yeah, okay. So we must add indicator like just thymol, thalline, okay? Okay, like methyl orange, okay? Methyl orange and so on, okay? So we must add indicator. Example of the indicator like this one, okay? So let's quickly take a look at the answer. Okay, just now. Okay, just now, A is a burette, B is conical plus. Okay, and then B1 and B2. Okay, we need to add indicator. Okay, methyl orange or thymolphthalein. Okay, okay, next. Okay, describe how the pH of the solution B in B changes as hydrochloric acid is added to the flask. Okay, so how the pH is changing. Okay, at first it's alkaline, right? The ammonia at first is alkaline. So how the pH will change? Okay, is it the pH will increase or decrease?
It
Okay.
pH
Mm,
decrease.
correct. Excellent. Okay. So it will decrease. We are starting with alkaline. Let's say at first the pH is like 9 or 10. Okay. So as we add acid, it will decrease. Okay. So it will decrease until neutral, until 7. Okay. Yeah. And then the indicator will change color. And then we know the reaction already completed. Okay. Okay. Next. Complete the word and symbol equation. Okay. So we have the word equation. Okay. Yep. This is the word equation. This is the symbol equation. Okay. So word equation, ammonia plus hydrochloric acid. Okay. So hydrochloric acid is here, HCl. Okay. Ammonia, the symbol for ammonia. Can you remember symbol for ammonia? The chemical symbol for ammonia. Okay. What is the chemical symbol for ammonia?
NH3.
Correct. Okay. So NH3. So for the symbol equation, NH3 plus HCl, it gives us NH4Cl. Okay. NH4Cl. So what is the word name for this NH4Cl? Can remember? NH4Cl, the name, the chemical name. What is the chemical name?
Mm,
Can remember?
ammonium chloride.
Yes. Ammonium chloride. Okay. Yes. Excellent. Okay. Okay. Question 4, 5, 6. Yeah. Still have a lot. So maybe we just do one more. Okay. We do one more and then we finish the class. Okay. Question 4. Okay. You are provided with a mixture of scandium oxide and copper oxide. Okay. Scandium oxide is amphoteric oxide. Okay. And copper oxide is basic oxide. Describe how you could obtain a sample of pure copper oxide from the mixture. Both solids are insoluble in water. Okay. Yeah. Okay. Let's see. So we have a mixture. Okay, we have a mixture with scandium oxide plus copper oxide. Okay, so both are solid, both insoluble. Okay, both insoluble
안젤리나 수업하잖아.
in water. Okay,
수업하잖아.
yeah. So solid, insoluble in water. So copper is a basic oxide. Okay, so it can react with acid only. Okay, scandium oxide is amphoteric. Okay, so amphoteric means it can react with both acid and base. Okay, so it can react with both acid and base. So what can we do? So means we will react with base. Okay, we react with base means the scandium oxide only will react. Then we can separate the two. Okay, so that's the main idea for this question. The copper oxide is basic, so it can react with acid only. The scandium oxide is amphoteric, so it can react with both acid and base. So in order to separate the two, we will react with base. Then only the scandium oxide will react, which means we can separate the two. Okay, so that's the idea for this question. Okay, so we will look at the answer. Hold on. Okay, we'll look at the answer. Yep. Okay, so what do we do? So we will add sodium hydroxide. Okay, so we will add sodium hydroxide or potassium hydroxide. So that's what we do. Okay, we'll react with base. Okay, so now, okay, stir and warm, the scandium oxide will react. Okay, so now we can filter to collect the copper oxide. Okay, we filter to collect the copper oxide. Okay, so first, okay, okay, this is our sample. Okay, so inside this sample, we have scandium oxide plus copper oxide. Okay, so now what we add the sodium hydroxide. Okay, so the sodium hydroxide and the scandium oxide, it will react. Okay, so the copper oxide, it remain as a solid. Okay, the scandium oxide will dissolve. Okay, because it react with the sodium hydroxide. So now we can filter. Okay, so we can filter the copper oxide solid will remain in the funnel, and then the scandium will be in the solution. Now it's aqueous. Okay, so now we separate the two. So now we can wash with distilled water. So we wash the copper oxide, make sure it's clean, and then we can dry the copper oxide on a window, a warm window sill, or in a low hour. Okay, yeah. So this is how we do it. Okay, yeah. So that's the idea. Okay, yeah. So now it's 10:45. It's almost time. So I think we can stop here, and then we can continue next week. Okay, what I'll do, I will send you this homework. Yeah, this homework. Okay, acid, base, and salt. I will send you the homework with answers. Okay, so you can try by yourself. If you have any question next week, we can discuss. Okay, yeah. So if no other question, we will stop here. Okay. Okay. Thank you. Thank you. Okay. Bye bye. Bye bye. Bye bye.